Hi, I'm Prof. Melko. Today we're going to talk about chemistry and the scientific method. So chemistry is everywhere. Obviously our devices like computers and iPhones, this is materials chemistry. Biochemistry looks something like this. We have delicious chemistry. We have thermochemistry, also known as physical chemistry. We have organic chemistry, shown as illegal chemistry here. And of course, chemistry jokes, the best kind of chemistry. Often they get no reaction, of course. Really, though, everything is lumped into modern chemistry. This is what happened after the 1600s when English scientist Robert Boyle first published his work, The Skeptical Chemist. Okay, so this was really the turning point. Before this, it was all alchemy, really just the people that were shouting the loudest and seemed most confident sort of were believed when it came to science. Not so different than, people in the media today that just yell the loudest are sometimes believed the most. But this was really the turning point when Bobby B, we're friends, I call him Bobby B. When Bobby B published The Skeptical Chemist, this really outlined what the scientific method was and really the need for experimental evidence. So basically, the two takeaways were opinions and theories are worthless unless they're supported by experimental evidence, and established the scientific method, which is now the basis of all modern science. So to get into the scientific method a bit more, this is really a systematic investigation. And that word systematic is really important, right? It means you're carefully collecting data and trying to explain some force of nature or some property in nature, right? And it's based on the results of an experiment. Now, after you do that, you usually have some initial proposal of this scientific principle, right? That's your hypothesis. So notice this comes after the data collection. That's sort of an important point. After much more investigation, more experiments, more data collection, you might be able to elevate that hypothesis, that initial guess. You might elevate it to a scientific theory or a natural law, or you might reject it altogether. Or you might just have to tweak it a little bit and revise it. So this really outlines in 3 steps how to apply the scientific method. It always starts with an experiment, right? You can't just guess a hypothesis. Okay, that's a common misconception. It always should be based on some experiment and data collection. Okay, so perform your experiment, make observations, write everything down, videotape it, whatever you have to do, record that data. Now you're going to analyze the data next and propose your hypothesis, right? Look at the data, maybe it trends in one direction, and you can extrapolate and propose some future measurement, right? Maybe use that to then explain some underlying, behavior of the atoms, right? After you have that tentative hypothesis proposed, you have to conduct more experiments, right? So it's tempting to just quit and say, I have my hypothesis, all the data supports this, must be right. But no, you need to keep testing that, right? Rigorously test it, have other people test it, conduct these additional experiments to test that hypothesis. And over time, as more and more people test it, and it turns out the hypothesis is still supported, then you might be able to elevate that to a scientific theory. Okay, and the word theory is a little misleading, right? It sounds like it might not be true. And I guess to some degree that's correct, right? These theories can be overturned, but this is a pretty strong statement. A scientific theory is supported by evidence and repeated experiments, okay? An analog is a natural law, but these things aren't necessarily the same, okay? So your hypothesis here is some initial proposal. So I'm just going to write that here. This is initial. After lots of testing, of course, you can have this scientific theory. And again, that's after a lot of experiments. Maybe other people have done the experiment as well and supported your notion, right? So both scientific theory and natural law are rigorously tested. Okay, there is a difference here though. Okay, the scientific theory and natural law differ in one major way. The natural law is something directly measurable. Okay, so you might say something like heat flows from hot to cold. You can measure that with a thermometer. Okay, the theory is not exactly measurable. It's proposing something based on the underlying fundamental nature of the matter you're investigating. So it could be that heat flows from hot to cold because of these little molecular vibrations that are happening at scales so small and times too fast for us to measure, right? So this scientific theory is not something that is sort of directly measurable with a thermometer or a barometer or a ruler. So not directly measurable. And that's really the main difference to keep in mind. Okay, so you have your experiment, you have your hypothesis, other people test it, you elevate it perhaps to a scientific theory and natural law, but it doesn't necessarily stay that way forever. Remember, we can keep testing these things and must keep testing these things to make sure they're still supported by data and the latest and greatest technology. Okay, so we could take a quick second to test ourselves. What's the difference between a hypothesis and a theory? Cue the Jeopardy music. Hypothetically, because I'm not paying for Jeopardy music. Is a hypothesis an initial proposal that is tentative? That sure sounds right. Is a theory a proposal that has been tested extensively? That sounds right. So A is a good candidate here. B, a hypothesis is a conclusion made after a theory was tested. No, that can't be correct. A hypothesis comes before a theory. C, a hypothesis is a proposal that's been tested extensively, whereas a theory is an initial stated proposal. No, a theory is not initial. That can't be right. D, nothing the words hypothesis and theory are synonyms. Definitely not. So the answer here has to be A. The last thing we're going to cover in this video is some different categories of modern chemistry. Right? Overall, there's various textbook definitions of chemistry, but really chemistry is about studying the composition of matter and the properties that go along with that matter. We divide this into a bunch of different kinds of chemistry. 4 are shown on the screen. Organic chemistry, that's really dictated to substances that contain the all-important element carbon. Inorganic chemistry is sort of the opposite, all other substances that don't contain carbon. Biochemistry, of course, is the study of substances composed or derived, I should say, from plants and animals. So your biochemistry in action. Green chemistry is probably the most recent type of chemistry, certainly on this list, but it's the design of chemical processes that reduce waste and hazardous substances. So those are sort of the various types of chemistry I want you to know about and have these textbook definitions. That sort of concludes this first video. We'll get into significant figures and scientific notation in future videos. You can check out my YouTube channel at Prof. Melko, subscribe to that and watch more videos, or check me out on Twitch, twitch.tv/ProfMelko, where I have office hours weekly and discussions of scientific news.